Okay, so all right. So what we are going to do now in this video is to look at three code files, number 9, 10, 11. So let's start with the strike cache block. Now, you could have used this in a programming language like Java. So sometimes at runtime, you don't know for sure whether your stack, for example, or in this case, vector, has elements or not, and you will be trying to execute a pop operation on an empty stack. So, or empty vector in this case again, sorry. So executing pop operation on an empty vector would lead to an error. But we may not be sure dynamically at runtime whether the stack is empty or not. Okay. So let's go through a code like this. Uh, let's say a stack is A4 is 10, and I do a pop of A4. The pop right now will be fine because the vector A4 has one element in it. Now, if I do another pop on it, it would lead to an error. And so let's save this as a Julia file. I could print it out, the first pop value. Mhm. Zoom in a little bit more. Okay, that's only the and save this. All right, so the first pop will print the 10, and then the vector is empty, and so it's going to print this error message. Now, if you have some statement following this pop operation, like for example, println some hello world or whatever text you want to print, or any even computation, uh, anything that you want. So any of those statements won't be executed once your program has an error message in it. Okay, or once your program generates an error. So how to handle a situation where, okay, dynamically there could be an error. That means the vector could be empty and the operation could generate an error. But I want to continue doing and executing these statements that occur after this pop operation. So in order to handle that, we need to use the try-catch block. So this is how we write a try-catch block. So you put all the risky statements inside the try block, and if any of those risky statements generate an error, you kind of handle that error in the catch block. And typically you handle the error by just printing an error message that what went wrong. And then, of course, you have an end statement that kind of is a delimitation of where the try block is beginning and where it is ending. So any statement after the end will continue to execute as if no error has been generated. Okay. So let's try to run this one. This is Julia 9. Okay. So the first stack prints an error message. So it prints the value 10 that was popped. And the second pop generates an error because the vector is empty. So since the vector is empty, if you don't have the try catch block, as we just saw in the earlier program, the program will generate the error message that you're trying to access an empty vector and just terminate. So, but when you once you have a try catch block, the control immediately goes to the catch block, and in this case, we have a print statement telling cannot pop an empty array, and that's it. And then comes out of the catch block and prints this statement continuing after the error, and then executes this addition 5 plus 2 is 7. Now, one thing you should notice is the error generated here in the second pop operation. So we have another statement inside the try block after this, that is statement inside try block. And we notice that that has not been executed, and that makes sense because the error gets generated in the second print statement in the try block. So the rest of the statements in the try block will not be executed. The control immediately goes to the catch block, and in this case, we have just one print statement there, printing the we can't pop an empty array, and the control then will come out of the catch block as well and continue executing the rest of the code. Okay, so that's what will happen. Now, if you have, say, two elements in the vector and try to run this code, now again, things are running as expected here. So again, the pop operation will remove the last element of the vector. So in this case, it will remove the 20, then it will remove the 10. So the vector is empty by now, so no problem because you're not executing any more pop. So the following statement, which says statement inside the try block, will also be executed. That will be printed. And the control doesn't go to the catch block in this case because only if there's an error in the try block, uh, getting generated, the control goes to catch block. Since there's no error in the try block getting generated here, the control doesn't go to the catch block. It comes out of the end, try catch block. After the end, you have these two print statements that print the print that the program is continuing after the error and also does the summation. Okay, so that's about the try catch block. Let's do tuples. So tuples are named, could be named or unnamed. So let's look at unnamed tuples. And what a tuple basically is a collection of values, or it could be also key value pairs, as we'll see in the case of a named tuple. And the main thing that you have to know about a tuple is it's not mutable. That means once you create a tuple with some elements, content, you cannot change it. You cannot change the tuple. So let's say you have tuple one that has basically the food items that we eat throughout the day. So let's say the potatoes are eaten in the morning, then chicken for lunch, chips as for snack, and vegetables in the din for the dinner. You print it out, and you can also print a particular element in the tuple by saying tuple 1 of 2. Again, tuple indexing like arrays and strings will start from 1. So when you say tuple 1 of 2, it's going to print the second element in the tuple. Let's execute this code and see what's going on. All right, so it's printing the contents of the tuple one, the first print statement, and then tuple one of two is the second element in the tuple, which is the chicken. And so it's a tuple of strings in this case because I am enclosing this strings within the text within double quotes. So it's a tuple of strings. Okay, now I want to make it like instead of just values, kind of like a key value pair. So for each value, I want to assign a key, kind of like a unique key as well. That means no key is repeated. And in that case, a tuple becomes is called as a named tuple. So I have here a named tuple, and I labeled as named tuple one. So it's not a keyword, named tuple one, and I introduce the key names as well. But note that the key names are not enclosed within double quotes. So they are not considered as strings, they are considered as keys. So this breakfast equals, and now the values are enclosed within double quotes because your strings, potatoes, then lunch equals chicken, snacks equals, say, chips, and dinner equals vegetables. Okay, since I zoomed in, things went like that. Let me see if I can pull it out like this. Hmm. So if you now try to print it, this is how it gets printed. Breakfast equals potatoes, lunch equals chicken, snacks equal chips, dinner equals vegetables. Now you can access specific elements in this name tuple as well by doing the traditional approach of indexing the tuple. So name tuple one of two. And also this is possible. So you can use the dot operator and say name tuple one dot whatever the key name is. Like say in this case, I say name tuple one dot snacks, then it will print the value of that key. So in this case, it will then just print the chips. Okay. And also when you try to print name tuple of one of two, it's not going to print the entire lunch equals chicken. It's just going to print only the value of that at that index. So the keys is mostly for our reference. But also, as you can see here, we can access the elements, the values of the tuple using the key names as well. Okay, so that's about tuples, not much about it. So tuples are also the kind of collections that um, uh, come into picture when you pass arguments to a function. So when you call a function, you pass set of arguments. So typically you pass like this, say arguments of strings, then you call like the four strings in this case, and you pass them to a function. So the arguments of a function are what is called as a tuple. So previously in an earlier video, we saw about functions. So this is now a tuple. Okay. So this is an integer. This is like a tuple where you have radius is both are float basically. Radius is float, height is also float. Now we could consider with a test if a tuple could have mixed data type. Yes, definitely possible, I would say, because the arguments to a function could be of mixed data type. One argument could be an integer, one could be a string, one could be a float, another could be a boolean, it could be of mixed type. So let's try it out and see. It could be just an ordinary tuple, tuple 2. And again, a tuple array starts with a square bracket. Tuple starts with this curly bracket, this bracket like this, not even curly, the one that you put like this. Okay, the curvy bracket like this. Okay, so let's name things like this. That's my name here, and let's say age and weight, and let's say it's a boolean. So let's say true, something like this. So this is tuple 2, and you can say println of tuple 2, and you can also say println of tuple 2 of index 3. save it and run it. Okay, so you can see here you could have a mixed data type because you could pass such mixed data types as a tuple as arguments to your function. So tuples should also allow mixed data type. Okay, so that's about tuples. So let's move on to dictionary. Now, dictionary, unlike tuples, is a mutable collection of key value pairs. And in a tuple, you could have just values, whereas in a dictionary, you need to have a key accompanied by a value. So it's always a key value pair. Now, there are three uh, kind of representations of dictionary in Julia. Now, the normal one or the traditional one is called the dict that stores the key values or the keys because the dictionary is accessed through the keys. And the keys could be stored in a random order. So there's no guarantee that the dictionary is going to store the keys in the order in which you are adding them to the dictionary. So let's see that. Now, before I go into the details of dictionary, make sure you're using this package called data structures. So this is where the first file that I mentioned, zero underscore uh, this one, zero underscore import underscore packages dot JL. So this file has all the packages that we need to add to the Julia environment in your system. So if you have not run it, this is the time to run that file. So let me open a new command window because if I run this, I cannot run any other program. So now we can run it. And if there's any update, if the packages are not installed, it's going to install them completely. It's going to take some time. If the packages are already installed, if there are any updates available for them, it's going to update them as well. So here it's updating some packages I have in this my Julia environment. So let it run. And since the packages are already there, it's just updating them. Uh, let's run the dictionary code. All right, and we'll go through the details now. Okay, so make sure when using dictionary, you're using this data structure. So the using uh, is a keyword, um, and it's like the include statement in C++ or import statements in Java. You have to include some packages or libraries when you're using some more advanced stuff. All right, so let's get into the details of dictionary. So the normal dict is a one that is normal dictionary and it stores things in the keys in random order. So in this case, I'm storing the keys like in this order. The first key is 1, the number 1, and the value for that is the string, the text 1. And the second key is number 2, and the value for that is 2. So when I try to print this, and of course, you're going to assign this a name, say my dict. So it's like a class object and so on. So I'm creating an object of this dict, okay? And I call it and I store it in by the name my dict. And when you try to print that, it should print, or we expect it to be printing the keys in the same order I'm storing here, 1 followed by the 2. But if you see here, it's not guaranteed though. Sometimes it may print like that, but sometimes it may print them in some other order. So things are stored in random order. So in this case, it's printing like 2 first and followed by 1. Okay. So if you want the keys to be stored, processed, and printed in the same order in which you're storing them in the dictionary, then you have to use what's called the ordered dictionary. So the ordered dict is the second variation of the dict dictionary in Julia. And the advantage that comes with using ordered dict is the keys are going to be stored, processed, and even printed the same order in which you're storing them in this dictionary. Okay. So I say again 1, 1, 2, 2, and I'm storing now in this object name. Again, giving an object name is up to you. You can name it whatever you want. But ordered dict is the name that you have to use. It's like the class name that you have to use to create an ordered dictionary. Likewise, for the regular dictionary, you have to use dict, and for ordered dictionary, you have to use ordered dict. So now when you try to print it, it's going to print 1, 1, and 2. So we are in this print statement. Let me try to make it little no, trying to get a white background for the command window and the text to be in black, but I'll figure out later. All right, so we are in this second, or yeah, okay, this is enough, good enough. So we are in the second print statement where it's printing 1, 1, and 2, 2, this one. All right, so let's now keep moving. Now I want to go back to my first dictionary, my dict, and add a third key to that because so far it has two keys. Of course, you are not guaranteed how the two keys are going to be stored. So let's add a third key now. And this is how you could add a key value back to a dictionary. You could say might dict of 3, in this case, the 3 is the key, equals the value here, which is the string 3. Okay. So that will add a key value pair 3, 3. And when you try to print it, this is how it appears here. So again, in this case, it's storing them as 2 first and 3 and 1. So there's no guarantee how things are going to be stored in the dict dictionary. So again, if you want to store things in a certain fashion, you have to use ordered dict. So go to the my ordered dict, and you can use similarly, you can say of 3 equals 3. So that will now create a key value pair 3, 3, and already you have 1 and 2, so it's going to append or add the 3 to that. So it's going to be like this, printed. Okay. Now, so if you want to get a collection of those keys, yes, we could get that. So there's a keys function that you could call, and to that you pass this my ordered dict, and it's going to then collect all those keys. Now, we don't get it as an array right away, we get it as a set. So what you could do is you could call the collect function that we used to make it an array in the earlier module explicitly and pass the key set as an argument for this collect function. Then it will generate an array of those keys. Okay. So you could even print that array. Look at its contents. So let's do that. So the keys array has values 1, 2, 3, and we're doing it on the ordered dictionary. Yeah. So we're doing it on the ordered dictionary. So the keys function just will put together in a set, And the collect function transforms that set to an array, and we can store that in some name and access the array. Now, we can also add the values of the elements in the array by using the sum function. So the sum is a built-in function name, a function that you can to which you can pass the keys array as the argument. So it's going to add up the values in the array and store that as in this variable key sum, and you can print that key sum. Okay, and that's what is printing as 6. Now, like you can collect the keys, you can also collect the values in the dictionary. So there is again a values function to which you can pass the my ordered dict. You can also do it on the dict object dictionary as well. And again, it's collected is first as stored as a values is a set of values to which you explicitly call the collect method and pass the value set, and that will get you a values array. And you can print the values array, which is now a collection of an array of strings, 1, 2, 3. This one. Okay. Now, I'm trying to show that I could change the value of a specific key that you already have in the dictionary. So I access that specific value or index using the key name. So my order dict of 2. So my order dict of 2 is this. Okay. And I want to assign it the value this to a lowercase t followed by wo. So you try to print it. This is how it gets printed. Okay. So the values for 1 and 3 starts with an uppercase character, whereas the string 2 starts with a lowercase character. So it's getting updated there. Okay. Now let's try to do something like this. Do we have to store the keys always like 1, 2, 3, 4, 5, 6 in increasing order without any jumping around of the values of keys? No, you could store anything as your key. So here I have another ordered dictionary. I call it as dict2. And here the keys are integers and the values are not strings, they are float. So the keys are like 1, 2, 4, 6, 9. So they're not in like increasing, continuously increasing. All it is increasing, but they are not like consecutive integers. Okay. So 1, 2, 4, 6, 9. So we could also try to insert something like this. We'll do that. Yeah, we'll do that. Okay. So this is the key 1 and the value 0 0.9, 2, 0 0.9, and so on. So I could print it. So let's try to print first. This is how it's stored here. So when you try to print this ordered dict here, it's also showing that the keys are integers and the values are real numbers. Okay. And that detail was not displayed when you had a key and as an integer and a value as a string. Okay. Uh, but it's getting displayed when it is. I'll try to find out the reason why it's not displaying there, but you don't need to worry too much about that. So we're going to focus on the contents, not on the data type. It's getting, we know the data types or the keys, it's an integer, and in this case, the value is a float, which is a real number. All right. Now, let me add another key value pair to this dictionary. This is say 3 is a key and this is 0 0.7. So I want to add it again. The keys are currently in this order 1, 2, 4, 6, 9. So the 3 0 0.7 is going to be added to the end of the current dictionary here. So the 3 0 0.7 is added here. 3 is not inserted right between 2 and 4. The keys 2 and 4. It's not inserted there. It's just inserted at the end of the dictionary. because it's an ordered dictionary. Its purpose is meant to store the key value pairs in the order in which the keys are added to the dictionary. Okay, so the 3 goes and gets added to the end of the dictionary. So now it leads us, so, and you can also do the collections. Okay, no, yeah. So you can also do collections and add them if you want all the float values and stuff like that. Okay, so now that we see the 3 gets stored at the end of the dictionary, the ordered dictionary, of course, it maintains what it's supposed to be, that it maintains the keys in the order in which we added them to the dictionary. But let's say there is a need to store the keys in a sorted order. Irrespective of when you are adding them, you want keys always to be stored in a sorted order. Then there's a third variation of dictionary called sorted dict that you could make use of in Julia. And here, whatever be the keys in whatever order written in the as the argument to the sorted dict, they're going to be stored in increasing order of the key values. Okay. So in this case, it's already in increasing order, so that's fine. So when you try to print it, it's going to be uh, like this, 1, 2, 4, 6, 9. Um, I think the printing of this in 64, all these details is depending on the versions you have. I may have updated. So this is a different computer than the computer in which I recorded the earlier videos. I'll go back and check whether it's printing the same thing there. But it's just a difference in the versions sometimes in Julia. The data type details may be getting also printed for certain collections, for certain data structures. Okay. Now, if I add the same key value pair 30.7, let's see where it gets added to the sorted dictionary. So it gets added here, 30.7, because it's the keys are sorted in increasing order, so the key 3 gets inserted there. Okay. And now previously I showed where you separately in two different separate statements, you first first get the set of keys and then pass them to the collect function and generate an array. We could combine those two statements even there into one statement where you say, I'll collect the keys. I'll get a set of keys by calling keys of dict3. And dict3 in this case is a sorted dict. You could do it on any dict you want. And pass that key set to the collect function, and that will generate an array of keys. Same thing, the values function, you can pass the dict3 object, and it will get you the set of values, and you can pass them to the collect function, and that will generate you the value array. And then you can call the sum function or the key array and value array and find the sum of the keys and values. So in this case, all the values were float. So you could add them and you'll get 3.3. And if you add all the keys, you get like 25. Okay, so dictionary comes in 3 variations in Julia. The dict, which is not guaranteed to store things in a certain order. It will store the keys in a random order. The ordered dict will store the keys in the order in which you're adding to the dictionary. The sorted dict will store the keys in the increasing order values of the keys. Okay, so with that, we'll stop this video.